What's up, guys? My name's Alexis, and I'm here to talk to you about the 7 characteristics of solids, how they work, and the tools that we use to better understand them and their processes. So the first characteristic that we're going to look at is the elasticity in solids. Most of us think that elasticity either comes from a rubber band or maybe a hair tie that's elastic because it stretches and then it bounces right back to its original shape. Well, there's a lot of things that actually have elastic in them, not just hair ties and not just rubber bands or anything rubber. Actually, a lot of clothing and a lot of canvas type shoes and the rubber in the shoes as well also have the elastic ability to be shrunken and then it'll pop back to the shape that it's supposed to originally be. So we're going to take one example, and I'm going to use a shoe and show you how it works. So let's take a look at this shoe. It bends and it looks all weird and like it's not going to go back to the original shape it was, but actually when we unbend it, like so, it goes back to its original shape without any issues. So the second characteristic we're going to talk about today is rigidity. Rigidity is an object's tendency to resist flexing or deforming. Usually when we think of these, we would assume glass or maybe a rock, but we could also look at a shelf. A shelf, whenever you put a heavy object on it, it doesn't bend or try to slope down. It still stays the same way. So what I'm going to do is I'm going to give you an example of this by showing you how when you put a weight on a shelf, even at the end, it still stays flat and it stays up on the wall and it doesn't bend or slide down. So let's take a look at Noah's Ark. As soon as I put it on the shelf, it neither bends and it just stays the same. It doesn't move in form, even when I move it up like so. It just stays where it is. So the third characteristic we're going to look at is resilience. This may be defined as the amount of deformation required in order to bring a material to its elastic limit, which is the point where the material will not recover its original shape. The example I'm going to use for this is a spring in a pen. When you spread the spring out, it's not going to go back. You're not going to be able to put it where it originally was in the first place. So we're going to see how this works by using this as an example. So let's look at the resilience in the spring of this pen. I'm going to push it past its elastic limit by stretching it out like so. Nothing is going to be able to help me put it back to the original shape that it once was. No matter how much force or no matter how much I try to squeeze it back in there, it's going to be all deformed looking like this. The next thing I'm going to talk about is plasticity. The plasticity of an object can be defined by the maximum amount of relative deformation that may be permanently imposed upon it. One of the examples I'm going to use is clay. You can reshape clay and you can make it into a different form, but it's still going to be clay. You're not going to be able to change that at all. And I'm going to show you how after you heat clay, it's not going to be able to be moldable anymore. It's going to stay the shape it is and it's not going to change. Next, we're going to look at mechanical working and forging. A lot of people know blacksmiths as people who create swords, and the way they do this is by using the mechanical working and forging to make the sword go to the place that they want it to be. I'm going to show you a video on how people do this process, how it works, and what they do in order to get the sword to look the way it does. So there is a technique called twisting that blacksmiths use in order to create a twist-like look in the metal. As you can see, when the metal is heated up like so, it's easy to bend like this. And then it gives it like a twisted look at the end. You can see an example of this on iron fences, such as stairwells, like in old houses that bend and go upward. The next characteristic I would like to talk about is malleability. Malleability is the process of which we hammer down metal into a thin sheet. The most malleable of all metals would probably be gold. We can hammer it down into a foil so thin that even a stack of several hundred sheets wouldn't be required to equal the thickness of a page. We also use a process called drawing. This process is when metal is pulled through a single die into a continuous ribbon of the same cross-sectional shape as the interior surface of the die. The property of the metal that allows us to be drawn is the wire called ductility. But One example that we use for drawing would be putting a sheet of gold on the back of a book and then gently crossing over, like I said, and making into the gold would then form onto the book. Another process that we use is rolling, which is when we put metal that is pressed through a series of paired heavy rollers into a continuous sheet. We can make things such as ladders and cars during this process. The next video I'm going to show you is an example of rolling and how we use malleability in a metal to shape it the way we want.
Roll forming is a process where a metal sheet passes through a series of roll stands that change the sheet's shape. The sheet undergoes what is called a profile bending. Roll form details are very common in, for instance, the furniture, construction, and car industry. It is possible to create advanced profile shapes in high-strength materials and many different materials.
Well, I hope you guys enjoyed my video on the 7 characteristics of solids and how they work in our world today. I'll see you next time.